Total internal reflection. Let us consider a ray of light passing from glass to air, that is, from a denser medium to a rarer medium. When a ray of light is incident on a refracting surface, a major part of the incident light is refracted and a small portion is reflected. The refracted ray bends away from the normal after refraction. That is, the angle of refraction R is greater than the angle of incidence I. Now, if we increase the angle of incidence, the angle of refraction also increases. And for a certain angle of incidence, say IC, the refracted ray grazes over the surface of separation and the angle of refraction will be 90 degrees. IC is referred to as the critical angle. Critical angle is that angle of incidence for which a ray of light while moving from a denser to a rarer medium just grazes over the surface of separation of the two media. That is, the angle of refraction is equal to 90 degrees. If we further increase the angle of incidence, the light ray, instead of getting refracted, bounces back into the same medium, obeying the laws of reflection. This is known as total internal reflection. Conditions to be satisfied for total internal reflection to take place are: the ray of light must travel from a denser medium to a rarer medium. The angle of incidence must be greater than the critical angle for those two media.
It will be very interesting to know that we never see the actual sunrise and the actual sunset because of the atmospheric refraction. We always see the sun 2 minutes before it crosses the horizon, before it comes to the line of sight. For the observer, same will be the case. We will keep seeing the sun for another 2 minutes after it has gone down the horizon. So we can say we always see the sunrise little advanced and sunset bit delayed. It's nearly 2 minutes. Again, the atmospheric refraction is coming into play, and what is happening? The atmospheric layers, the sunlight is entering, coming to the observer, crossing many of the atmospheric layers. The outer layer is rarer because of the heat of the sun, and the density of the air is low there compared to the next one, and so on and so forth. So the light ray which is coming from the sun, even when it is below the horizon, will suffer refraction and it will bend towards us like this. So if sun is here, so actually what is happening, in place of reaching straight to us, the ray is bending because of the refraction, because it is entering from rarer to the denser medium. And that gives us impression that sun is somewhere up. Its apparent position is higher than its actual position. That is the case of the sunrise. Similar phenomena will take place in the case of sunset. When the sun has gone below the horizon, for some time, because of the bending of the rays coming from the sun, we will have its position, its apparent position seen little above the horizon. So that is all because of the atmospheric refraction in the different layers of atmosphere. Another phenomena that takes place because of the atmospheric refraction at the time of sunrise and sunset is flattening of the sun's disk. You must have observed at the time of sunset, the sun looks little flatter at the top. So this flattening of the sun disk is also because of the atmospheric refraction.